So let's see benefits of cloud. Cloud computing has actually numerous advantages, many advantages. So the first one is one can access applications as utilities over the internet. What it means, user can access applications as services over the internet, manipulate and configure the applications online at any time. Of course, any user can manipulate and configure applications whatever they want to use. We can configure and manipulate online at any time. It does not require installing software to access or manipulate cloud applications. So users does not require to install any software to access or manipulating the cloud applications. Whatever softwares or applications you are using on cloud, you don't need to, for that purpose, you don't need to install any specific software to access those things. And the next one is cloud computing offers online development and deployment tools, programming runtime environment through PaaS model. So cloud offers online development and of course online deployment tools, programming runtime environment through PaaS. Means what is that one? Platform as a service model. Next, cloud resources are available over the network in a manner that provides platform independent access to any type of clients. So here, let's see, cloud resources are available over the network, of course, in a manner that provides platform independent access to any type of clients. What is platform independent here? Of course, all of you guys know about this thing. Previously we had discussed, and in the coming sessions also we are going to discuss about the topic. Here, suppose for example that server or cloud server is running on mainframe and your users PC or end users PC is running on Windows platform. So there is no problem. You can access those applications over internet, right? So we don't need to worry about the platform. Either it is a software or hardware differences. It does not give any problem. That's independent, platform independent. Next one is cloud computing offers on-demand self-service. The resources can be used without interaction with the cloud service provider. So here, what is on-demand service? Simple. On-demand means nothing. When you want to, when you are going to request, or when you are going to, sometimes maybe within a short notice of period, user needs some additional hard disk storage space or some additional application. So you can directly use those resources without interacting with the cloud service provider. That's completely in your hands. So next one, cloud computing is highly cost effective because it operates at high efficiency with optimum utilization. Optimum means it's a maximum utilization, the best utilization. So it just requires an internet connection. So cloud computing is highly cost effective, of course, because it is highly cost effective. It operates at high effective efficiency, means the productivity with the best utilization or top notch utilization. It just requires an internet connection. Next, cloud computing offers load balancing. Here, let's see, we need to talk about load balancing. What is that one? Let's see. Yeah, just want to move this screen. Cloud computing offers load balancing that makes it more reliable. So let's see, for example, what is load balancing. I'm giving you just for your idea. A website or web application can be accessed by plenty of users at any point of time, right? So if you are at a time, many number of users can access website or web applications. Maybe sometimes it will happen, like you can check the examination results and all those kind of things. Right? It becomes difficult for a web application to manage all these user requests at one time. So of course it is really difficult for that web applications to manage all these users requests at one time. It may even result system breakdowns. Of course, if all users are trying to or requesting the web applications to access their resources or their utilize their options, so maybe it causes to system breakdowns. So for a website owner whose entire work is dependent on his portal, the shrinking feeling of website being down or not accessible, and also brings lost potential customers. So what will happen? So for this website owner, as a website owner whose entire work is dependent on his portal, whatever work they are doing, whatever users are trying to access from information from that website, so obviously that website working capability will be dropped. So obviously they may chance to lose the customers. So here load refers to not only website traffic. Load refers here, load balancing in the sense, load refers to not only website traffic. It is not particularly related to website traffic, but it also includes CPU load, network load, memory capacity of each server. So a load balancing technique makes sure that each system in the network has same amount of work at any instant time. A load balancing technique makes sure that each system in the network has same amount of work at any instant of time. This means neither any of them is excessively overloaded nor underutilized. Right? I think it's clear. Now let's see the disadvantages of cloud. So what are the disadvantages or risks? Better we can use the word risk of cloud. So of course cloud it is a promising innovation with various benefits, and it also has some risks. So we're going to discuss a few risks when we are using cloud. So first one is security and privacy. What is this? It is the biggest concern about cloud computing, right? Since data management, so data management and infrastructure management in cloud is provided by the third party. So here, just we are going to access the application as a user. We are going to access the applications or cloud or internet, right? So data management and infrastructure management in cloud is provided by the third party. The entire infrastructure and the data management is provided by the third party. So it always risks to hand over the sensitive information to the cloud service provider. So let's say, for example, we have a Gmail account and we are storing and saving some information or mails, important mails in the cloud, a Gmail cloud server. But it's not in our machine, right? Information at the third party, that is a Gmail server. So it's obviously it's a risk to us because we are handovering that sensitive information to that Gmail service provider. So although the cloud computing vendors ensures highly secured passwords, protected accounts, highly secured password protected accounts. Yeah. So any sign of security breach may result in loss of customers and business. Of course, the cloud computing vendors ensures highly secured password protected accounts. Maybe if any security threats or breaches may happen, then what will happen? Obviously, they will lose their customers and of course business also. So this is the first risk by using cloud. And next one is lock-in. So it is very difficult for customers to switch from one cloud service provider to another. So it results in dependency on a particular cloud service providers for service. So if you want to user wants to change from one CSP to another CSP, it may be a bit difficult. So the third one is isolation failure. What is this? The risk involves the failure of isolation mechanism that separates storage, memory, and routing between different tenants. Let me show the screen. Yeah. The risk involves the failure of isolation. Isolation is here, of course, nowadays everybody knows what is isolation. That's quarantine. That means separation, because it's a corona time. So of course, everybody knows about isolation. What is isolation? The risk involves the failure of separation mechanism. What it will do? It separates storage, memory, and routing between different tenants. Right? This is also, if maybe separation will be failed or isolation will be failed, it's again a problem. It's a risk. Next one. Management interface compromise. Management interface compromise. So in case of public cloud provider, the customer management interfaces are accessible through the internet. So of course, if it is a public service provider, the customer management interfaces are accessible through internet, right? So a risk, especially when combined with remote access and browser vulnerabilities. So if we are using, if our cloud provider is a public cloud provider, then of course customer management interfaces are accessible through internet. Of course, we are going to use interfaces by using internet only. So of course there may be a risk. So especially when combined with remote access and web browser vulnerabilities. The last one is insecure or incomplete data deletion. Insecure or incomplete data deletion. What is this? It is possible that the data requested for deletion may not get deleted. So as an end user, if you are going to send a request for data deletion, maybe sometimes that data will be stored somewhere. It might not be deleted. It happens because either of the following reasons. What are those reasons? So what are those two reasons? One is extra copies of data are stored. But that extra copy is not available at the time of deletion. That's the one reason. And second one is a disk that stores the data of multiple tenants is destroyed. These are the two things that comes under insecure or incomplete data deletion. Right? That's it. Now let's see. We are trying to know about what is grid computing. Grid computing is a type of distributed computing that combines the resources of interconnected group of several independent computers that communicate through the use of a network in a way that makes them look and act like a single computing entity. Right? So grid computing is a type of distributed computing. Fine. So that combines the resources. Of course, grid computing combines the resources of interconnected groups means different networks of several independent computers, of course, that communicate through. So these computers are communicating through the use of a network in a way that makes them look and act like a single computing entity. Right? So the group of connected computers connected through different networks, but what we think it will act like a single entity. but those were connected through different communication networks. That is, this is called grid computing. So each computing task is broken down into smaller pieces. So whatever computing tasks we are providing to that grid computing, that is broken down into smaller pieces and distributed throughout the available computing resource for execution, right? So these pieces are processed in parallel, and as a result, completion is achieved in a smaller amount of time. Fine. Now, how does grid computing works? Let's see. Grid computing works by running specialized software on every computer that participates in the data grid. Okay. The software acts as a manager of entire system and coordinates various tasks across the grid, right? So grid computing works by running specialized software. So of course it needs a specialized software on every computer, whatever computers in the grid. So entire all the machines will have that specialized software, so that participates in the data grid. Fine. So that software acts as a manager of entire system and coordinates various tasks across the grid, right? Specifically, the software assigns subtasks. So that software assigns subtasks to each computer. So these specialized software assigns subtasks to each computer, so they can work simultaneously on their respective subtasks. So after the completion of subtasks, so whatever subtasks allotted to the machines, so after completion of these subtasks, the outputs are gathered and aggregated to complete the larger scale tasks. Fine. So the software lets each computer communicate over the network with the other computers, so they can share information on what portion of subtask each computer is running and how to consolidate and deliver outputs. So after completion of all these subtasks, of course, the outputs are gathered and aggregated to complete the larger task, and the software lets each computer communicate over the network. So the number of computers are communicating each other over that network, so they can share the information. So all those computers in those networks can share that information on what portion of subtasks each computer is running, so whatever tasks they are doing, right, and how to consolidate and deliver outputs. So this is about grid computing. Now let's see what is utility computing. Utility computing is a process of providing computing services through an on-demand, means whenever user needs that one, right? So utility computing is a process of providing computing service through an on-demand, that is pay per use billing method. Utility computing is a computing business model in which the provider owns and operates and manages the computing infrastructure and resources. Whenever user wants or user demands, then the computer service will be provided, and this model is pay per use billing method. And utility computing is a computing business model in which the provider owns, of course, operates and manages the computing infrastructure and resources, and the subscribers accesses it, means users can access it, who are the subscriber can access it, and when required on a rental or metered basis. Fine. So this is called utility computing. This model is based on used by conventional utilities such as telephone services, electricity, and gas. Of course, you can easily understand this concept. So if you have a telephone connection, right, or postpaid mobile billing connection, so of course, how much you use, that much you pay, right? This model is called pay per use, right? So the principle behind utility computing is simple. The consumer has access to a virtually unlimited supply of computing solutions over internet. See, the consumer, a user, can access to a virtually unlimited supply of computing solutions over the internet or a virtual private network, that is VPN, right, which can be resourced and used whatever it's required. So whatever resources is required, so he can use that much. So the backend infrastructure and computing resources management and delivery is governed by the provider, right? Cloud service provider. So now let's see Saas, software as a service. Software as a service, also known as SaaS, it is a cloud-based service. Instead of downloading software and on your desktop, so if you want to use any particular software, you need to download the software into your PC and install. You need to install that software on your machine. So here, software as a service means a cloud-based service where instead of downloading software on your desktop, or PC or business network, whatever it is, to run and update and access an application via internet browser. So you don't no need to install that particular software on your machine. So of course you can directly access that software from the cloud service provider, that is called software as a service, SaaS. The software application could be anything from office software to unified communications among a wide range of other business apps that are available. Of course, you can use any kind of software applications by using cloud, like that is from a simple office software to large combined means simply what we can say is that's large enterprise, what we can say, enterprise communications among a wide range of other business apps that are available. So SaaS, software as a service, users subscribes to an application rather than purchasing it once and installing it. So user need not purchase that software, right? So they need not purchase it and they need not install it on the user's machine. So users can log. So here let's see, users can log into and use a software as a service application from any compatible device over the internet. So of course end user can log into that software as a service application from any computer or compatible device, or mobile or PC or desktop or anything by connecting through internet, right? So a software as a service application may be accessed through a browser or through an app. So we can access it through a browser or an app, a simple app. So online email applications that users access through a browser. Of course, if you are using a Gmail account, you can access it through browser, such as Gmail and Office 365 are common examples of software as a service applications. So these are so many things are there, so many examples are there, but these two are the better examples to easily understandable by us, right? So the last one is cloud computing. Cloud computing. Of course, you know what is cloud. So cloud computing is on-demand availability of computer system resources, especially data storage, and computing power without direct active management by the user. So whatever resources are cloud storage, data storage services, or infrastructure services, or software services, whatever it is, whatever you demand, whatever user demand, so that the whatever user required, those facilities or those resources can be available on demand, and we can access those resources or those services without direct active management by the user, right? The term is generally used to describe data centers available to many users over internet. So that's it. This is about just a simple things about what is cloud computing, what is software as a service, what is utility computing, what is grid computing. So this is for today.